A common question we get from readers and from students in our Design Patterns Bootcamp course is about using Java lambda expressions with the strategy pattern. Our book, Head First Design Patterns, and our course both use Java to demonstrate how to implement a design that incorporates the strategy pattern. And one thing some people notice about our examples is that our strategies are functional interfaces. So here we have the fly behavior and quack behavior interfaces, and they're just simple functional interfaces. That means they just have one abstract method. In our duck simulator example, the flying and quacking strategies are both functional interfaces, which means that the concrete strategies that implement those interfaces can be expressed as lambdas. Now, the traditional way to implement the concrete strategies is to define a separate class, for example, squeak, that implements quack behavior, that simple interface. That means it just needs to implement that one method, quack. Then we need to create a squeak instance to assign to a duck, and we do this in the rubber duck constructor. Now, using lambdas, we can replace both the squeak class and the code to create a new squeak object with this simple code instead. In other words, just one lambda expression that prints out squeak. Lambda expressions are essentially syntactic sugar that replace creating a class that implements a functional interface and an object that instantiates that class. In my opinion, the main benefit of using lambda here is that you reduce the amount of code you need to write and save writing an entire class file. And in this example, where we have a lot of small strategies, we'd save a lot of code writing. However, one thing to keep in mind is code reuse. In this small example, where I'm using this strategy only once with rubber duck, using a lambda expression like this is fine. But what if I'm going to reuse the squeak functionality over and over again with many ducks? In that case, we'd be better off defining the squeak behavior just once and passing it into the ducks that need to use it. In that scenario, we can use dependency injection. We'll create the duck behaviors in the duck simulator class and pass the behaviors for the ducks to their constructors. So, for example, we'd modify each of our ducks to include a constructor that takes a fly behavior and a quack behavior, like I'm doing here in the rubber duck. And then in the duck simulator class, we'd first create the behaviors, saving them in variables so that we can reuse them for multiple ducks, and then pass those behaviors into any duck that needs them. Now we get the benefit of code reuse and the shorthand of the lambda expression. Now keep in mind, your strategies may be much more complex than our simple duck behaviors, and so many strategies will not be simple functional interfaces. In that case, you won't be able to use lambda expressions as shorthand for your strategies, and you'll have to build them the old-fashioned way. For instance, think of how the strategy pattern is used in the model view controller compound pattern. Here, the strategy pattern is used to organize the relationship between the view and the controller. You can think of the controller as a strategy, or a set of strategies, for how to handle various actions in the view. So your controller will likely contain many methods that the view will call, depending on what action the user takes, clicking a button or choosing a menu, for example. And so it's likely that your controller will be far more complex than a simple functional interface. You can find the complete code for the duck simulator at our GitHub repository, learn how the strategy pattern works in Chapter 1 of Head First Design Patterns, and learn how the model view controller works in Chapter 12 of Head First Design Patterns. If you want to learn lambda expressions in depth, you can read Chapter 8 of the Java SE8 study guide. And if you're a Safari Books Online member, you can sign up for our Design Patterns Bootcamp course at their live online training page. We hope you enjoyed this video, and don't forget to subscribe.